All right, continuing on with section 7.7. This one is entitled Single Variable Addition Equations. And the next four sections are kind of interesting because we're going to be looking specifically at each of the operations, addition, subtraction, multiplication, and division, and solving them in equations. So this time I want to go over a couple terms that we'll see kind of coming up. So first, this one, which we probably recognize, we have our variable. And the classic variable is, of course, x, is often used. And it simply means we use it to represent a number, quantity, or expression. And our key here is we're often trying to find it or isolate it. For example, say we have an equation. And remember, of course, this is an equation because it has an equal sign, not an expression. In this example here, x only has one possible number that it can represent. Anything else would make this equation false. And what I could do is I can see, of course, that, well, what number plus 3 is going to be 5? Well, I can see that x equals 2. But I can use what's called the inverse property. Let me make sure that I say it right. The subtraction property of equality. To solve this. And that simply means this. If A equals B, then A minus C equals B minus C. And this means simply, if I have A and B equal, I need to subtract the same thing from both sides of the equation. And we've been talking about things like this for a while, so this should not come as a surprise to anyone. It's more likely that you just haven't seen it written quite like this before. So if I was going to use this property here, I'm trying to isolate my variable. And that's another thing I want to quickly touch on. Let me find a different color that I like. And this simply means when I write this x equals 2, on this side right here, x is isolated. There is only x and no other operations or numbers on that side. And that simply means that I know that I've solved it. And that is good, because that means I've done my problem. So, well, returning up to our x minus 3 up here, to get rid of that plus 3 in my attempt to isolate my x and keep my x on the same side, I'm going to write x plus 3, then I'm going to write my minus 3. Because plus 3 minus 3 is going to be 0, and then I'm going to have x all by itself on this side. But just like my subtraction property of equality says, if I subtract 3 from this side, I must also subtract 3 from this side, and simply that's how I get my 2 and how I get to my answer. Now, this is a very simplistic example of when I use this, but it's important to use a simple example so we know the answer, because they will get more complicated than this, and even much more complicated the more that we go in math. So let's take a look at some quick examples and how we can solve them or isolate the variables using this example. Okay, they're going to give us this. X plus 36 equals 90. All right, so for this, you only need to show that one intermediate step. And for this one, I can write a couple. I can write this one, x plus 36. Now to get rid of that 36, because I'm trying to get my x all by itself, I'm going to subtract 36. And if I subtract 36 from one side, of course I have to subtract 36 from the other side. So I have x equals, and 90 minus 36, well, if I do that in my head, I think that is 54. At least I'm pretty sure that's what that would be. And here I go. I am good to go. And I've kind of showed that one intermediate step. Now, all of the questions in this section are going to be pretty easy because they're pretty much going to be exactly this. And you're just going to kind of practice and get it down all the ways that we can solve this. And then as we go further into this chapter, it's going to get much more difficult as we go. So I'll just do one more example because I don't think this is going to be particularly challenging. X plus 27 equals 35. Okay, in this case, we're going to do the same thing. X plus 27 minus 27 equals 35 minus 27. I have x equals, because 27 minus 27 is 0. 35 minus 27, I think that is 8. All right, there we go. Go on and do it. I'm going to do one more if you want to see. Now, I dropped my marker, so I'm going to have to write my example 3 in a different color. Let's see. We've got y plus 1.7 equals 6.5. All right, even if they're not a whole number, I can still do it just fine. Plus 1.7 minus 1.7 equals 6.5 minus 1.7. Okay, I've got y equals 6.5 minus 1.7 should be 4.8. Yep. There we go. Good to go. All right, good luck.